Now this problem says, Pamela requires 3 hours to swim 15 miles downstream on an Illinois river. The return trip upstream takes 5 hours. Find Pamela's average speed in still water. How fast is the current? Okay, so a problem like this requires a formula, and that formula is dirt. That means distance equals rate times time. So that's what we're going to use here. Now I like to use this formula in a table. So I'm just going to set up a table really quick with this formula. So I'm setting this up with a D here, and that equals R times T. So that's our setup. So when I look at this, I look at Pamela requires 3 hours to swim 15 miles downstream. So 3 goes here because 3 is the time. 15 goes here because it's 15 miles. And the return trip, so I know if it's a return trip, it's the same amount of miles. So that's 15. And that takes 5 hours. Now, the first thing they said was upstream, or downstream and then upstream. Downstream simply means I'm actually going with the current, and upstream means I'm going against the current. So that current is either helping me or hurting me. So I'm going to split this in 2 pieces, at least for the rate. So when I think of that rate, I'm thinking of, if I'm talking about Pamela, I'm going to call her P. And the P is going to stand for her speed. So speed of Pamela. And then I'm going to call C the water speed. And they call water speed current. Okay, so when I look at those, now think about this. If I'm going downstream with the water, that current is helping me. And if I'm going upstream, that's going against the current, that current is hurting me. So I'm subtracting C or adding C here. So now what I'm going to do from here is, now I have to set up my 2 equations. Now remember how that formula was. So now we're just going to set up these 2 equations. So this is going to be 15 equals, and I'm not going to multiply this out, I just want to write it, so I want you to see this. So 3 times P plus C. And then the other equation is going to be 15 equals 5 times P minus C. And the reason why I didn't have you guys multiply it through was for this reason. I can simply, for this first one, divide both sides by 3. And those are going to cancel there, which is a lot nicer than distributing it through and going through a lot of algebra for that. So this is going to turn out to be 5 equals P plus C. And then I'm going to do the same thing with this other one. I'm going to divide by 5 both sides. So this is going to be 3 equals P minus C. And the nice thing about this is, notice I have 2 equations, 2 unknowns for both those equations. And the C's are already opposites. And that will always be the case with these. That's what's nice. So what I can do is I can just add these together, use the elimination method, and get my answer pretty quickly. So those C's are going to cancel. This is going to be 8 equals 2P. So then P equals 4. So Pamela is going 4 miles per hour. So then to find the current, I can just use one of those 2 equations. So I do know P plus C equals 5. And I know Pamela's 4. So the current C has to equal 1. Okay, so what I can say here is, for Pamela's speed, it's 4 miles per hour, and the current is 1 mile per hour. So there's that problem.